to fully understand atomic spectra, okay, these are the selection rules. Delta S equals 0, so the change in the total spin angular momentum must be 0. Delta L must be 0 or plus or minus 1. Change in little l must be plus or minus 1. We talked about that when we talked about the hydrogen atom. Delta J must be 0 or plus or minus 1, although J0 to J0 is not an allowed transition. Okay, you can get a summary of all the allowed transitions by generating what's called a Grotrian diagram, and you can do that by going to the spectral database. Okay, so here's a Grotrian diagram for helium. Okay, and you'll notice you have here in your Grotrian diagram, you have your term symbols listed. Okay, and you have all your singlets here in one, right next to each other. You'll notice you can only have transitions from singlets to singlets, triplets to triplets. Okay, so delta S must be equal to 0. So when you lay out your Grotrian diagram, you put your singlets side by side. That way, you can indicate, because you don't expect triplets and singlets to cross. Okay, transitions between singlets and triplets are not allowed. And then delta L must be equal to 0 or plus or minus 1. What do you notice about this Grotrian diagram? Okay, you can only have transitions between S and P, P and D. Okay, you don't have a D to S transition, because that would be a delta L equals 2, right? D, remember, L is 0 for an S term, 1 for a P term, 2 for a D term, 3 for an F term. So you only get transitions in neighboring stacks here, okay? And then, of course, we talk about delta L, small l. Like if you're going from a 2p orbital, if you're starting from a 2p orbital, you can only end up 1. Either in an s orbital, like a 3s or a 4s or a 1s. Okay, but you cannot go to a 3p. Okay, because that would be delta L equals 0. P to P would not be allowed, and you cannot go to a 3d. Because that would be delta L equals 2. And so if you switch from one electron configuration to another electron configuration, the L quantum number of the electron that switches cannot change by more than 1. Okay? And it must change by at least 1 L quantum number. And that's the end of this lecture.